let's go on. For a moment, I need to think about, like I said, what is the impact of all this process on you as a subsurface scientist, as a production geologist, as a production engineer, as a development scientist? You know, what is the impact of all the changes that the rocks have gone through? Now look at these different examples here. The first one, you have a huge, very good definition or very good expression of this surface reservoir rock. These are on the surface, okay? But you also see that there are boundaries separating the different phases of the position. And then look at the other one. So the questions you'll be asking yourself is, do I have a trap here? Because in this case, they're not folded, okay? They are not squeezed to form a trap. What is the connectivity, both vertically and laterally? And I'd like someone to type in a chat room, what do you think in terms of connectivity? For this figure A, are we going to have better connectivity horizontally or vertically? For the A and B, what do you think? Are we going to have things like, if I put a molecule of fluid in a particular layer here, will it move horizontally? Is it likely to move horizontally or vertically? Let me get your reactions. Okay, so I see for A horizontally, okay, horizontally, and then I think for B also correct. So horizontally or lateral, that's both correct. Why? Because if you follow my cursor, these are like boundaries, and these boundaries, you can imagine that they compartmentalize the reservoirs vertically, at least on this section. So if I'm imagining that I want to drill a well, I will keep in mind that this is one compartment. Between this one and the other one, there is a separation. Question is that separation, is it a baffle or a barrier? I like to keep that in mind while I'm planning my well. And then I also want to keep that in mind while I'm doing a volume assessment. If I'm trying to calculate how much hydrocarbon is this reservoir rock able to hold, I will also imagine that this is a boundary here, and then the one below is also a boundary. I keep that in mind. Same goes to this one. Okay, and then as you're doing this, you're also thinking about the size of the reservoir. You remember what I said? If it came from fluvial or river settings versus when it came from desert or aeolian, or if it's a beach rock, they have different geometries, they have different properties. So the environment or the source of the reservoir is also very important in your characterizing it in terms of the size, the geometry, in terms of the porosity and permeability, in terms of connectivity. It is very important because you can see these are both surface reservoir rocks, but guess what? They have different geometry, different expressions. Even in terms of baffling, they have different boundaries, different expressions. Okay, and now imagine these two below. The one below on your left, for example, bottom left, that's figure C. You know what comes to mind? If imagine that this layer here is your reservoir where you have my cursor. Question is, what are these faults really doing? If I have hydrocarbon, if I have oil here, let's assume that this dark layer is able to seal it up. Let's say it's a seal rock, or it's able to prevent the hydrocarbon from escaping. The question is, these white lines, which are called faults, as a result of, again, stretching. Remember we talked about stretching of the rocks or extension or some kind of, shaking of this terrain that caused this thing to, fracture and broke into these pieces that you're seeing. Question is, these faults here, are they helping to keep hydrocarbon within this reservoir rock, or is it going to act as a conduit such that the hydrocarbon will leak and get to the surface? That's the question that you ask yourself. Another question is, if the whole of this is reservoir rock and I'm trying to drill a well from the surface to get here, how much oil will this hold? How much hydrocarbon does it hold? How much gas will I find there? Okay. Another question is, how many wells do I need to develop it to get the oil out of place? Because there are many small compartments here. This is one, this is another one, this is another one. That means I will need several wells. Do I want to do that? If I want to do that, what's the profitability here? How much am I going to get? So these are things that you have to think about. Again, keep in mind, this reservoir rock did not start like this. They started off clean, nice, continuous, not faulted, not broken like this, not folded like you're seeing on figure D. But then life happens and things happen. They get stretched and then it forms the figure C. They get folded or squeezed, it forms the figure D. They get compartmentalized by difference in conditions or difference in the sediment input, or and then you see the upper figure. So ultimately, what was initially simple and continuous and not consolidated, very porous, has become buried, in other words, porosity has reduced, has become shattered or folded or faulted, in other words, permeability and porosity has been impacted, and then that also impacts how much hydrocarbon that reservoir rock can hold, and I'm now worried about how much can I get, how much fluid is there. Okay, so this is like trying to, like, you know, put it together so that you have to think about this and ask yourself what matters. Okay, I'm seeing your comments. C is highly complex, and that's very true. In fact, the other question is this even going to hold hydrocarbon in the first place? Because everything looks like if I put a molecule of hydrocarbon here, it's going to go all the way and leak off. Okay, even if there are reservoir rocks there, does it even hold anything? Okay, I don't see. So these are questions that we all ask, and very good points that are being made here.